Good afternoon, everybody. My name is Guillaume. I work at Bordeaux Control Tower. My presentation is about aircraft engines, so I hope that after my presentation you will be good at mechanics. After a quick introduction, I will describe the four main types of engines, which are piston engine, jet engine, turboprop, and turbofan, and then I will conclude. So, aircraft engines were invented at the beginning of the 20th century. They evolved a lot. Their reliability has been improved, and this has allowed the transport of passengers. So there are different types that I will describe. The point of my presentation is to describe how engine works, and finally to say which engine goes with which type of flight. So we'll begin with piston engines. So the first type of engine that allows long flights, because there still are really reliable. They are efficient at a low altitude, so from ground zero to flight level 200. That means 20,000 feet. So you have different settings. You have pistons arranged like radial engines, like a star, and you have pistons arranged like an H. Radial engines. So some pictures here: F-4U Corsair, World War II fighter with a radial engine, and here a DR-400, a famous club light aircraft that we fly in clubs, especially in France. So how does it work? It's the same principle as a car engine. It runs on petrol. There are pistons that move in cylinders, and the vertical movement is converted into a rotating movement by a crankshaft. And the main part being driven is a shaft, and at the front of the engine you have a propeller. So let's have a quick look at how a propeller works. So you have blades. Sometimes you have 2, 3, 4. You can have up to 8 blades. You have a hub at the center. So let's imagine a side view of the propeller. So here it's the profile of the propeller, and the propeller produces thrust the same way a wing produces lift. So you have this force, this thrust created, this force created by the propeller that makes the plane to move forward. You have two types. There are two types of propellers. Variable pitch propellers. Here you can see that the blades are articulated around the hub. You have a fine pitch. It's like the first gear in your car when you want to create a huge amount of thrust when you want to accelerate. You have a coarse pitch. It's like the fifth gear on your car when you are cruising. And finally, you have a reverse pitch when you want to brake. In fact, you produce thrust on the opposite side. And you have constant speed propellers. So you can see on the picture that the blades are fixed. It's one piece of wood here. And it's cheaper, it's simpler, and it's less efficient. But for light aircraft, it's efficient enough. We move on to the more modern type of engine, that is turbojets. So you can find them on commercial planes and jet fighters, such as Mirage 2000. They were invented in the 30s by Frank Whittle before World War II. They are efficient at high altitude, flight level 200 and higher. They pollute a lot, and they are very noisy. So it looks like that. How does it work? So you have cool air that is sucked into the engine. Then it is mixed with fuel, and it burns in a combustion chamber. and the exhausting gas produce thrust. So while they're exhausted, the gas also drive a turbine. The turbine drives a shaft, and the shaft drives the initial compressor. So it works like a closed circuit. So move on to turboprops. We can find turboprops on aircraft such as Canadair, which is a water-bombing aircraft, or on helicopters. We see the two turbines. It's a compromise between a turbojet and a piston engine. I will explain why. And they are efficient at medium altitudes, from flight level 100 to flight level 200. So here you have the turbine, and then you have the propeller in front of the engine. So how does it work? You recognize the turbojet with the compressor, the shaft, and the turbine. So the parts being driven by the shaft is a gear train. The gear train, the purpose of the gear train is to make the propeller turn at a lower speed than the compressor. And the thrust, is produced by the propeller. And there is just a tiny amount of thrust produced by the exhausted gases, but compared to the thrust produced by the propeller, it does not count. So the last type of engine are turbofans. So we can find them on modern aircraft such as the A380. They are efficient at high altitudes, from flight level 200 and higher. They pollute less than turbojets. They are cleaner. I will explain why. They are extremely reliable. So it looks like that. A huge fan on the front. So you recognize again the turbojet, and in front there is a huge fan and a bodywork that the purpose of this bodywork is to guide air into the engine. So the main shaft drives the external fan, and this fan produces 85% of thrust. So the 85% of thrust is produced by what we call a cool stream, so it's just clean air. And you have 15% of thrust produced by the what we call the hot stream, that is exhausting gases. So it's very clean engine. So to conclude, today we choose the engine according to the type of flight. I mean that when you want to perform a short flight at low altitude, you would choose a piston engine equipped aircraft. For medium haul flights, you would choose a turboprop because they are efficient at medium altitudes. For long flights, you will use a turbofan because it's very reliable and it consumes less petrol than other types of engines. Turbojets are still used for jet fighters because they deliver power very quickly. Even if they pollute a lot and they are very noisy, they are still used because they are very efficient. If you apply full power, you have full power in 2 seconds. So for jet fighters, it's the best choice. And for tomorrow, in the future, in the short term, improvements are underway to reduce CO2 emissions and fuel consumption. And we also want to improve the reliability more and more. And in the long term, we will have to concentrate on new sources of energies, like solar-powered engines or electrical-powered engines. My ending slide is a picture of what might be the airliner of the future, an airship with electrical powered engines and solar panels on the on the top. So if you have any questions, I will be happy to answer them.
20 seconds.